Hello and welcome back, everyone. So continuing on, before we begin the implementation of this new project, we're going to spend just a few minutes on some concerns that came up in the forum after I posted that introduction video to session 9. So Lee, with that, let me go ahead and hand it over to you.
Yeah, there was two comments in particular that came up that sparked my interest. One was by Elp Trauma 360, who had mentioned that he was interested in seeing the new camera systems. There's really not any new camera stuff that's going on quite yet. The camera systems that you saw here are just stripped down versions of the camera system that I put together in the third-person character controller. So, or the third-person camera system, whatever you want to call it.
Right.
But basically, I just stripped out a lot of the collision checks, and I modified one for Shannon just so we could run around. Also disabled the ability for her to die and slide. It just made it easier for testing. And then the other one that you'll be seeing here shortly is one that we put together for the gyrocopter, who was our winning entry. And I can't remember who did that for the life
come
of me
on, it
right
was
now.
Thacky.
There you go, Thacky. I just couldn't remember his name.
I know, it's late. It's been a long day.
14 hours or something?
Wow.
Yeah, I know. Not all of us like to stay up 4 days in a row.
Yeah. Continue.
But so that being said is basically we're not going to be really creating any new camera systems.
While working through the terrain system, we are doing new camera systems for the actual MMO.
Well, the MMO will have a whole brand new set of cameras. I think when we were discussing it, there was probably going to be 5 or 6 different camera systems that we're going to have to put together.
Yeah, there's several.
Yeah, so there'll be plenty of camera system stuff. But as far as this part of the R&D, they're just going to be modified versions of the third-person camera. And
again, that allows us to it allows us to focus quickly on, kind of the mission at hand, which is getting this terrain system complete and behind us.
Right. We may play with modifying it a little bit more heavily towards the end when we are wrapping up the sculpting part of it, because in one of our R&Ds I had implemented a Maya-style camera for doing our sculpting, and that seemed to work out well. So at some point during this project, we may go and create a camera that works like a Maya camera would, with holding the Alt and middle mouse to drag in or the slide your screen, the dolly, pan, zoom in, all that kind of fun stuff. Mm-hmm. So, but that, again, is not going to be right now. This is like later, many hours from now. But the other thing that I wanted to show in this video is we're demonstrating kind of how fast Shannon is capable of moving with this new train system. And then Jason had made a post about being able to run in excess of 600 miles an hour. And what was funny is while he posted that, and I didn't realize it, I was tweaking some of the code so it would do a raycast check on the train to prevent us from falling through. And if we did fall through, the reset us back on top of the train. And he had posted that, and I saw it. I was like, oh, no, not really. I can go at about 1,500 miles an hour now. So, which for you guys that want a comparison, that's about the top posted speed of the F-22 Raptor, or about Mach 1.9, I think it is. So, I'm going to hit play. And I'm going to look at Shannon here, and we can see I've got her speed set to 550. Now, this is not the full, I think it works out to be about 1,450 some miles per hour at 650. But because we're recording and streaming this, I can't get to that full speed without breaking the editor, but I can dial down the 550, which still works out to be about Mach 1.6.
And that is very important to remember, and that is because of the streaming technology that we're using. This is running on Lee's machine. Of course, there's being screen caps grabbed, sent over here to mine. And Lee's not on a high-end performance machine. So that does indeed put a bit of a load over there. So once the streaming system is down, then Lee finds that running at 650 runs nice and smooth. But still, even being able to demonstrate this at 550 is pretty darn awesome in my opinion.
Right, and even when we were demonstrating 100 before, and I'm going to put 100 now just to show the difference of that little raycast jack.
Mm-hmm.
Even with 100 before, we would occasionally fall through the terrain. So at 100 now we just keep going. So this is 100 meters per second, or 223 miles an hour.
And I hate that these guys are seeing this at a capture of 10 frames a second
because we're already probably halfway across the level by the time they see a frame update. But so I'm going to reset this real quick. I'm going to adjust a couple of settings, mostly on the main camera. I want to set my max distance so I can get a little bit further away from the camera, or from the character. So we'll do 50 on that, and we're going to take our run speed back up to 550.
Yeah, just as a reminder, with the camera being close, remember the camera can now go through terrain because the camera's been simplified a bit for us to be able to do some of these tests that we're doing.
Right. So now I'm going to back out a little bit.
So you're gonna see blue because we're cutting through, but
and you also see it as we're first loading in those patches.
Right.
So because the way this is set up, it loads patches that are in the view frustum of the camera. So the further out the camera goes, the more patches it's got to draw. Now, we had also mentioned that at Shannon's run speed, our test for the amount of space amount of patches that we rendered out on this train, it took 28 minutes or so to reach the end of the world from the center of the world that we rendered. Now, I'm going to get ready to go right at about the 1 minute mark. So we've got a nice even number to work with. And we're going to see how long it takes to run off the edge of the rendered world with a speed of 550 meters a second.
So 4 seconds, get ready.
Here we go, and go.
Dun, da, da, da. Yeah, that's just crazy. Remember, this is actually smooth on Lee's screen.
Yep, so now I'm
11 seconds?
Almost there. Yeah, 11 seconds. So I'm at about 500 and 7,000 meters.
18 seconds.
I hit
you snagged
I'm off,
off the world. About 21 seconds.
About 21 seconds. Now, at normal run speed, that takes 28 minutes to do that. So we're talking about her normal run speed is 5 meters a second. So at this speed, that takes 28 minutes to get there. You saw every patch being loaded in at a speed of Mach 1.6. So
that's a pretty sexy proof of concept.
Yeah, but I think it works out to be a little over 1,300 miles an hour that we can do this with streaming.
Mm-hmm.
And then I get about another 200 miles an hour. Another 225
Streaming mean
miles.
You're streaming your screen to me, not patches from the system.
Yeah, exactly. Streaming to you, because right now we're using
the
GoToMeeting.
GoToMeeting, right.
Yep. So the stream it. So you're capturing my screen as I'm playing it, and then you're using other software to downsample that and capture your screen of what you're seeing at 10 frames a second.
That's right.
So what you see is nowhere near what I see.
Right. Those that are following along with us, they're going to get the privilege of seeing this on their computers, again, from following along with us and producing the same stuff. Right. I know we've got a lot of students that are doing that. And speaking of students, there was one more concern, Lee, that I wanted to get you to talk about.
Yep,
that was brought up.
That's the bigger concern.
Yes.
The bigger concern is when we brought up the drawing and we started talking about our workflow, and I can bring that drawing up again. That's the other thing we need to talk about. You guys may have noticed that things were a little bit fuzzy on the last video. That was my bad. I had the resolution set on my desktop too high, so you get a little extra compression.
Yeah, you may have noticed my audio was a little bit worse than normal, and that was my bad. For whatever reason, the audio had got switched over to the webcam instead of our mic system.
Right. So things got a little dicey on that last one, but it was mostly just talking about stuff, so it wasn't that bad of a deal. We weren't showing code. But back to the drawing, when I was talking about the workflow, we had mentioned that with the way that we're writing this train exporter and overriding the default FBX importer functionality, and then building out asset bundles, and then using asset bundles being streamed in, that we were going to make use of a pro-only feature. Now, the concern came up, and I think it was Lyric that brought it up, was what does that mean to everyone out there that doesn't have the pro version of Unity and are just using the standard? Does this mean that you're out of the out of the project? Can you not move forward? And that's not the case. With what we're doing and what we're going to be covering for this first part of it, which is the train editor, which is, again, built off the technology that we've been going over the last couple months. And the data storage system, this train generator, all this code will give you a functioning world that you can play with, run around in, and work. And all
And used for your actual game.
Used for your actual game. This is none of this is going to be leveraging the power of something that's going to limit you if you don't have pro. So if you have standard, you can still follow right along up to the point where we get to the train exporter. Now, everything from the train exporter, some of it that you can, the customization of the FBX importer you can still do, and you could export the OBJ files out to Maya, mess with them, convert them, bring them back in, but you can't export them as asset bundles, and you can't stream them in like we're going to. So you'll have to use those OBJs as a traditional prefab, just like you would with any other mesh that you brought in from your third-party modelers. So you can still use this technique that we're going to be doing with the viewer if you just use the prefabs. If you want to bake everything out, modify it, and bring it in as a standalone prefab and skip the streaming step, you can do that.
That's right.
There are trade-offs, though. And the trade-off is going to be the fact that you're going to be limited to what you can draw on your particular machine, as well as how fast you can build the meshes. So if you don't bake out these OBJs and you just go with the train system, what you're going to end up with is going to be something similar to what I want to show you now, which is the train editor that we're going to be working towards building. That's going to be this guy. Now, this is kind of an intermediate step. This is where my editor is without the sculpting tools, because I've not reintegrated the sculpting stuff into here. You'll also notice that Shannon is not in this project. So got to wait a little bit because we've got to initialize the train generator. There's the gyrocopter.
Yep.
So,
awesome.
And as you can see, as I'm spinning around, all the train patches are loading in. So, and normally I would have less than this, but I've loaded up more train patches than I normally would, just to demonstrate that the train editor is capable of a decent amount of draw.
Sure.
Not as much as you would get normally. And if I pause real quick, we can see that we're running at still, around 200 frames a second.
On a non-gaming computer.
On a non-gaming machine where we're streaming. And I'm still using soft shadows. So if I turn those off, I'll get some more frames per second. My draw calls will drop down a bit.
Yeah, but you're talking about someone that would be following along with Unity standard anyway.
Yes.
So
They don't have soft shadows. So this is still completely functional. And if I go ahead, hit F1, and I can fly around. Now, as I move, you'll see that we're getting some of the performance before. In other words, we're just usually rendering, or we're bringing in the meshes only in the direction that we're facing. I can show that a little bit better if I actually bring up the camera. So you can see where I'm pointing is where it's going to be loading in patch information. So, and this caches out, so if I decide to backtrack and turn around, we can see that it will load the patches fairly quickly. And I can zoom back out. And it's a nice chunk of terrain.
Yeah.
So it's not bad. It's not as efficient as what we get with asset bundles. And the other limitation to it is the fact that we're losing draw call, or we're losing draw calls. We're sacrificing draw calls because of the way we're doing our meshes. So if
Yeah,
I
we're
pause,
picking up more draw calls.
Yep. So if I jump on over here and we look at our patches, turn off lighting to make this a little bit easier to see. A single patch in this system is only 9 by 9 vertices. So 81 vertices in total, which is what's allowing us to create these with our meshes as fast as we are, is because there's so little vertices to be calculated. So we can do this very quickly. On the flip side, though, we have to have an awful lot of them to be able to render it. So if you were to look at it, what's that? That's 2 by 2, so that's 4. That's 3 by 3. That's 4 by 4. It's 5 by 5. That's 6 by 6. That's about the size of a single patch in our final system. So now where this is taking hundreds, we're looking at 762 managed patches. We could do with probably 25 of the patches that we'd have normally, or in our current viewer with the
streamed approach with
yeah,
the asset bundles.
Asset bundles. Thank you.
You're welcome.
I was like going, no, I know what they are, really. But with the streamed approach using asset bundles, we just get a lot of performance for that. But I guess that's probably why they made it a pro-only feature.
That's right. So the moral of that story is, for those of you that are following along with Unity Standard, you're not out, in the woods, left all by your poor self.
It's not game over. You don't have to pack it up and go home.
You can still do all the prefabs. They just need to be in your project.
Yep.
You cannot start streaming in asset bundles.
And you do have one thing that we lost. So you do have an advantage. I can't show it right here because I don't have it. But if you use this technique in this system and you decide, hey, this is all I need for my game, you also have the ability to edit in-game.
Yep.
Because this system will allow you to have enough performance that you could edit these meshes in real time, which is something that we sacrificed for in trade so we could have more terrain and the ability to travel faster, right, which were in our particular case a much greater priority for us than to be able to have to edit in real time. Because when you think about it, how often do you really going to be editing your terrain when you're trying to play the game?
Right.
So.
All right. Is that pretty much everything that you wanted to get covered, the concerns?
I think so, yeah. I just wanted to cover the concerns, let people know that if they don't have Pro, that it's not the end of the line for them.
Okay.
And that I also just thought it was really cool to show Shannon running at Mach 1.6.
Unfortunately, they just can't see it at a true couple hundred frames a second, but still. All right.
Well, you can just take that video that you're watching and then speed it up to about 100-fold, and it's about the same.
Yeah, but it just looks so much better when you're able to see it smoothly flying over all that stuff.
Yeah.
But all right, we'll go ahead and wrap this video up so that in the next one we can get started finally with the new project at all. Thanks a lot, everyone.